RIP stands for Routing Information Protocol. Routing Information Protocol. Routing Information Protocol is a true distance vector routing protocol. RIP sends the complete routing table out of all active interface every 30 seconds. For example, this is the router 1. These have 3 interfaces. In these 3 interfaces, we apply routing or RIP on these only 2 interfaces. Then in every 30 seconds, RIP sends all routing information or routing table throughout these 2 interfaces to the next neighbor. It relies on hop count to determine the best way to a remote network. For example, this is a network, or you can say this is a LAN. For reaching this LAN, router 1 have 2 paths. The first path have 2 hop counts and the second path have 1 hop count. So the least is preferable. So R1 choose this path via RIP because RIP have hop count as a metric, but it has a maximum allowable hop count of 15 by default. So a destination of 60 would be considered unreachable. For example, this is hop count 2. If we have 15 hop count, then it is okay. But if we have 16 hop count, then this network is unreachable. RIP works okay in very small networks, but it's super inefficient on large networks. So nowadays we are not working on RIP. RIP have 2 versions. The RIP version 1, or you can say RIP 1, and the second one is RIP 2. RIP 1 only uses classful routing, which means that all devices in the network must use the same subnet mask. This is because RIP version 1 does not send updates with subnet mask information. RIP version 2 provides something that called prefix routing and does send subnet mask information with its route updates. This is called classless routing. You will rarely see RIP version used in today's network. Even RIP version 2 does not get much attention. So why I am even telling about RIP version 1 or RIP version 2? Because it helps us explain routing protocols a little better before we get into the much more advanced. Now we are going with the practical. We have this scenario. To configure RIP routing, just turn on the protocol with the command router RIP. And tell the RIP routing protocol the network to advertise. Remember that with static routing, we always configure remote networks or the network that are not directly connected, and never type the route to directly connected networks, because in static router because in static routing, router have information about directly connected networks. Dynamic routing is carried out the completely opposite way. A network that is not directly connected under your routing protocol only enter your directly connected networks that configure the network. First, you need a simulator that is Cisco Packet Tracer. Now we are configure the basic structure of our network, that is this. I'm already configured the basic network architecture. Here this network is 10.0.0/8. This IP is 10.0.0.1. This IP is 10.0.0.2. And this network is 20.0.0.8. This IP is 20.0.0.1. Here this PC have 20.0.0.2. This PC have 20.0.0.3. And this network is 30.0.0/8. This IP is 30.0.0.1. This PC have 30.0.0.3 and this PC have 30.0.0.2. Let's configure. This is our R1 router and this is our R2 router. In R1 router, we can check the IP addresses of the interface. For command is show IP interface brief. We need to go enable mode. Show IP interface brief. You can see here IP address for 0 by 0 f 0 by 0 is 20.0.0.1 and the fast Ethernet the IP 0 by 1 the IP is 10.0.0.1. Now for R2 show IP interface brief, you can check in configure. If you want to check on show command or if you want to run show command in configuration mode, just type do before the command. Do show IP interface brief. Just enter. Here you can see this IP is assigned to F0 by 0 of this router and this IP 30.0.0.1 is assigned to fast Ethernet 0 by 1, that is this. So now configure the RIP routing protocol. Just go to configuration terminal. Now type the command. The command for enabling router information protocol is router RIP. Press enter. Now you enter in router configuration router mode. Here you apply the routing protocol, but you need to advertise the directly connected network. In static routing or in default routing, we advertise the not directly connected network, but in the dynamic protocols we define or we advertise a directly connected network. Here for router 1 there are two networks are directly connected, that are 10.0.0./8 and 20.0.0.0/8. So here I am typing a command for advertising the directly connected networks, that are network, and the type the network, that is 10.0.0.0. Press enter. Because RIP does not support subnetting, so we do not use here the subnet mask. The second network or the command for advertising second network is network. The second network is 20.0.0. Press enter. Now by default router or by default the RIP follows the auto summary command. Auto summary means if we use, for example, if we use two networks like 10.0.0.0/24 and 10.1.0.0/24. These are two different networks, but RIP treated these networks as a single because RIP auto summarize all the network. These are two class A networks, so RIP summarize is as the /A. It means these both are lies in same network for RIP. So we need to run a different command, that command is no auto summary. Press enter. After no auto summary, RIP have two versions. So if you want to apply second version, just type version 2. Here you can check 1 or 2. You have two options. Here I am using 2. Press enter. If here I am using version 1, then this command is not working properly because version 1 is not, because the version 1 does not support subnetting. This is all command for enabling routing information protocol. The first one for router RIP. This command is enable the routing information protocol on router, and the network command tells the routing protocol which classful network to advertise. By doing this, you are activating the RIP routing protocol on the interfaces whose address falls within the specific classful networks configured with the network command under the RIP routing protocol. It means here I'm type network 10.0.0.0. It means whichever the interface have this network, on the same interface RIP is applied. Same is for applied for this command also. Whichever the interface have this 20.0.0. network, that particular interface is applied RIP. Now we are applying RIP on second router or route R2 also. Just type router RIP, press enter. Now type network command. There are two networks. The first one is 10.0.0.0. Press enter. The second network is 30.0.0.0. Press enter. Now no auto summarization because RIP follows auto summary by default. Now we are using version 2. So here I am applying version 2. Now you can check the routing table. For checking the routing table, go to enable mode, just type show IP route. Here you can see this is R2 and this is R2. This is not directly connected via 20's network, but in routing table of R2 you will find 20's network, and if this router wants to connect to 20's network, it will use fast Ethernet 0x0, that is this. So for going to 20's network, this router sends packets from this interface. This shows 120 is the AD for RIP protocol and 1 120 is AD for RIP protocol and 1 is metric, that is hop count. So this network have 120 AD and it is one hop count away from this router. Here you can see R. R means RIP. So this route comes from RIP routing protocol. And for router 1 you can check show IP route. Here you will check R. It means this route comes from RIP protocol. This is a destination network that is have CIDR as 8. 120 is AD, 1 is hop count, or you can say metric for RIP. Via 10.0.0 it is connected via 10.0.0.2, that is forwarding address for this router. This router have forwarding address this, and this router have forwarding address of this IP. And it is connected with FA0 by 1 of its own interface. Now the next command is show IP protocol. Here you can check routing protocol is RIP, sending updates every 30 seconds. It means RIP sends packets or RIP sends updates or its routing table in every 30 seconds through the all RIP enabled interfaces. Next, during 30 seconds, it means routing table will be sent after 30 seconds from now. Just check now. After 7 seconds, after 4 seconds, and now again it starts from 30. Now after 27 seconds, the routing information base or the routing table will be sent. And if a router not receive any update from neighbor till 180 seconds, then that particular route flashed out. It means the route is invalid after 180 seconds. It means if update received within 180 seconds, the route is regenerated or recreated in routing table. So the whole time is 180 seconds. The network is hold in routing table for 180 seconds only. If the packet is received within 180 seconds, that route is refreshed. Now routing table, routing for networks are 10 and 20. Version 2 is sent and version 2 is received. For the version is belongs to RIP version. RIP version 2, it means for R1 it sends version 2's packets and it also receives the version 2 packets. Fast Ethernet 0 by 1 sends 2 packets and receives 2 packets. Fast Ethernet 0 by 0 sends 2 packets and receives also 2 packets till now. The maximum path is 4 for RIP. Now the next topic in RIP is holding down RIP progression, or you can say holding down RIP propagation. You probably don't want your RIP network advertised everywhere on your LAN. For example, I have these routers. This is network 1, this is network 2, this is network 3. I don't want to include this network in our RIP protocol. So we use a command that is passive interface. By using passive interface, this router does not send RIP updates through, through this network or this interface. If we apply passive interface command for this interface, then RIP not then RIP will not send RIP updates throughout this interface. There are few different ways to stop unwanted RIP updates from propagating across your LAN, and the easiest one is through the passive interface command. This command prevents RIP updates broadcast from being sent out of a specific interface, but it still allows the same interface to receive RIP updates. Means this interface does not send RIP updates, but it will receive all RIP updates. It only not send the RIP updates, but it receives all RIP updates. So the command for enabling this passive interface is